Now we're going to discuss about speed control of synchronous motor. Okay. Um, Before going to what are the types of speed controllers available in synchronous motors, we know some few things about the synchronous motor constructions. The synchronous motor construction is not only almost, it's a completely same for synchronous generator. The construction wise, there is no difference. Okay, it's a run at synchronous speed or it remains standstill. Okay, so speed can be varied by varying supply frequency because we know the synchronous speed is 120 F divided by P. Frequency is directly proportional to synchronous speed. If you are varying the frequency, definitely the synchronous speed should be varied. Due to unavailability of economical variable frequency sources, this method of speed control was not used in past and they are mainly used for constant speed applications. But nowadays is the development of semiconductor variable frequency sources such as inverter, cycloconverter allow the use of synchronous motor in variable speed applications. Okay, so that purpose only we are going to be uh, generate different gate pulses of the power semiconductor devices. Through that we are varying the voltage or current. Okay, then we can able to vary the speed easily. Here some types of speed control techniques are available. Okay, wound field synchronous motors, different types of common synchronous motors are wound type synchronous motor. Okay, next one is a permanent magnet synchronous motor. Some cases hysteresis motor or synchronous is the reluctance motor. Okay, all these kind of synchronous motors having a starter with a three-phase winding is connected in AC source. So our converter design is to control the inverter output. Some cases fractional horsepower synchronous reluctance and the hysteresis releases motor employ a single phase starter winding. That is special cases. But major applications we are prefer for three-phase winding. Here the first method is true synchronous mode. This true synchronous mode, the real converter is the AC supply is fed to the rectifier. It's convert from AC to DC. Then this inductor is to act as a smoothing the output of DC. Again, this capacitor is uh, to act as a filter and remove unwanted things present in the DC output. Then we get pure DC. That pure DC is provided to the VSI. VSI is nothing but is a variable source inverter. Okay, but yeah, our objective is to vary the voltage. So here we use it for specific controller. In this, if you are frequency command in true synchronous mode, we given the frequency command. F star is indicated as a frequency command. Okay, depend upon the frequency, the delay will be generated. Okay, that frequency is converted to the time. Okay, frequency is converted in terms of time, then fed to the inverter. At the same time, the frequency level will be varying, the flux value will be varying, the flux in terms of voltage. Okay, that amount of voltage, how much amount of voltage we need to vary, okay, in terms of firing angle. So specific controller we are using. Through that controller, we are changing the firing angle. Okay, if you are varying the firing angle of control rectifier, definitely the output voltage of DC varying. What's the DC will be varying? The DC is nothing but it is a input of inverter. So definitely the inverter output also varying. Okay, this is the one kind of variable voltage generating method. Okay, through that voltage varying, the synchronous motor or permanent magnet motor or wound field synchronous motor or synchronous reluctance motors or any kind of hysteresis motors. Okay, all kind of synchronous motor speed can be able to control. Here, in the speaker characteristics when that frequency value is very minimum. Okay, for example 0.1, something like that. The value of frequency value is minimum at the time. The frequency and the voltage are directly proportional. That means a linear relationship. Whenever the frequency will be increasing, the corresponding voltage also increase. But the frequency, once they reach the base frequency level, again the frequency value will be increasing, but the voltage is not varying because the voltage are constant when the frequency reached for base frequency. So frequency variations also limit depend upon the voltage value. Okay. In this graph, if you are reach the maximum torque, the frequency is not adjusted. Okay, the frequency is not adjusted. Once the torque is constant, okay, so the frequency is not affected the torque. Next one, self-control mode. In the self-control mode, we can able to generating variable voltage and variable frequency in one converter. That converter is something is a inverter. Here, the input is DC. That is a PWM inverter. So that can be inverter is converting from DC to AC. That AC is fed to the synchronous motor. Okay. Here in stator and the rotor point, we need to measure the output value, especially RPS, rotor position sensors is placed in the rotor. Otherwise, optical sensor or absolute magnet position encoder. Okay, any kind of encoder or optical sensors are used to sense the output of rotor. Okay, this output is generating the actual value is fed to the controller. But in the controller, actually what we needed, how much amount of output we needed, we provide one command. Okay, in this diagram, we are focusing delay command. Okay, not delay command, it's a controller input. Okay, different words are using. Here we are using for delay command or controller input, whatever it is. Okay, that input value is compared to the in controller having one comparator. That comparator compares that input value at the same time for actually output voltage from optical sensor or rotor position sensor. Both the comparisons, it's provided some deviations. Depend upon the deviations, the controller generating the triggering pulse of the inverter. Okay, based upon that error, uh, the controller will be generating the gate pulse. That gate pulse is fed to the inverter switching terminal. Okay, based upon that controller output, the inverter output will be varying. Okay, so we can able to varying the voltage and the variable frequency for in single inverter mode. That is a self-controlled mode. Okay, in some cases, self-control mode in rotor pressing, especially for rotor pressing sensors. Okay, if you are varying for two variations, one is show the diagram. Three-phase AC supply is fed to the phase control rectifier. Okay. This phase control rectifier is converting from AC to DC. Again, the LC to act as a filter. Okay. Under DC link voltages, it's provided constant DC output. That constant DC output again fed to the inverter. That inverter output is fed to the synchronous motor. Okay. This is a open loop control. Suppose if we need to for closed loop condition, we can measure output voltage or output current or rotor position. Okay. In this diagram, we can measure for two. One is a rotor position, next one is a voltage. Separate sensors are there. If you are based upon the voltage value is generating in terms of actual speed. Okay, already we are set the speed. So this comparator is compare the set speed and the actual speed. Okay, that comparator provide error for actual and the set speed. That error is fed to the phase control rectifier. Based upon this error value, the phase control rectifier will be varied. So definitely the output of DC voltage will be varying depend upon that error. Like that. Again, that the controller output is fed to the inverter input. In this case, if you are measure the rotor position sensor based upon the rotor positions, okay, it is generating the frequency command. That frequency command output is affected to the inverter output. Based upon that frequency command only, the inverter output will be varying. Okay, so already the input of DC is vary based upon that rotor position. Like that, here frequency command is varying for the inverter. Based upon these two, we can generate variable voltage and a variable frequency output. That output of inverter, that inverter output is fed to the synchronous motor. This is also one mode of self-control uh, controller using synchronous motor. Okay, some cases true synchronous mode. In this true synchronous mode, the speed of motor is determined by external independent oscillators. Okay, there is no comparisons. Okay, there is in this control and this control method, there is no need for actual output. Okay, normally the AC is converted to the DC through the diode rectifier. Here the DC value is not controlled because diode is an uncontrolled element. So it just convert from fixed AC to fixed DC. Okay, we will provide the constant output we are using for DC link voltage. Then that DC is fed to the inverter. But here the crystal oscillators generating the voltage and the frequency. Based upon that voltage and the frequency value, the inverter output is varying. Okay, in this inverter itself, I think this inverter is a PWM inverter. So that inverter can capable to generating voltage and variable voltage and variable frequency. That variable voltage, variable frequency is fed to the synchronous motor. These are also one kind of speed control method in synchronous generator. Suppose now a technology self-controlled synchronous motor drive employing a load commutator thyristor inverter. Here simply source having one converter, load side having one converter. So totally two converter. Source side converter to act as a rectifier, load side converter to act as a inverter. Okay, in this diagram itself, we can clearly understand. Okay, if the three-phase AC supply is fed to the source side converter, it converts AC to DC. Again, that inductor to smoothing the output voltage of converter. Again, that pure DC is fed to the inverter. Okay, that inverter is converted from AC to DC to AC. That AC to fed to the synchronous motor. Here, both converters having using for ACR. The ACR, the gate pulse. Okay, we know that a separate controller we are using to generate the gate pulse. If you are varying the gate pulses, the operation of the ACS also based upon the gate pulses, it's to act as a generator, sorry, rectifier or inverter. Okay, in these load side converters also can capable to variable voltage and variable frequency. Okay, these are the important uh, speed control methods available in synchronous motor. Thank you.